Here we are with the PCB, bright red. Looks very simple. Check a 3D model. There you go. Very simple. This was the programming header, the switch, the capacitors, crystal, and headers. See, the 3D models didn't load in for here because I think I've actually made these ones, but let's see. There we go. I think I actually made this one. Anyway, what is wrong with this board? Quite a bit. Let's start off. Overlay is missing for the header pins and could have been added. So what I mean by this is the solder mask overlay. Could have been added here, would have been known the shape of your component, would have been easy for manufacturing, like actual placement, because imagine if I placed this capacitor all the way over here and pin headers have like a little black outline only for the plastic, it just would have been unmanufacturable essentially. So good to have that solder mask layer around, even supposed to be over here. Really should have had one here, even something as simple as this really, that would have done the trick. Anything would have been better than nothing. Missing revision number of board and date, details to keep track of what the board is what. So I could have added like a revision date to see if I had to make any changes. I could have referred back to. It's just to keep up to date what this board was and you know what revision it was in. It's just a little of control really. I forgot what the term was really for it. It's called, see if you actually caught this one, C1 and C2 are, oh this is bad, oh dear, this is bad. C1 and C2 were the opposite of what they were supposed to be. As you all might know, the largest capacitors go first and the smallest one, because the largest one is the one that acts as like the bulk capacitance almost and prevents brownout and things, and the small ones are for the higher frequencies to filter out noise. And as you can see here, they are reversed. Luckily this board is nothing too complex, but it generally, you want it on the other end. It's how it's meant to be, it's how you're supposed to do things. Even in the schematic it was laid out like that. And my brain just didn't register. So learn from me. Don't do what I did. Could have introduced more ground pour around crystal lines as you don't want a signal near it. Could potentially affect it. So here, let's say I could really move this one here. And this one here. And if we report polygon, report all, and then we've got a bit more ground in here. So this one would have been really much better. This is what I would really just these small things. Even I could have really separated this out a bit more and allowed more ground pour to flow in. As it could, you know, especially for crystal lines, it could potentially affect other signals, especially, you know, if I wanted to do something here, I don't want a noisy signal. It is what it is, and it wasn't that bad. But again, more is better. Doesn't hurt. I've wrote another note. Perhaps a brief note could be added for what the switch does. And since we did have the space, so I could have put switch one changing a voltage header or something. Voltage, I don't know what you put, but it's like a simple brief thing what that switch is meant for, to keep note if someone does grab up the board like program here and program here. And we do have all the space in the world for this. I've just put the board name here. So I could have done much better with that. Of course, there are other things. I think the routing could have been a bit more better. Maybe it seems a bit messy and jumbled. And generally with that, I'm still trying to get better at routing microcontrollers and just routing in general. I find it quite difficult, I guess, with everything spewing all over the place. It's not very fun. Doesn't look very neat, so to speak. Could have made the board smaller, I guess, because really I don't think the larger board would increase the price. So I'm trying to keep costs down. I like things more compact anyway. But yeah, fairly simple board. Quick summary before we end off the video here. I'd just like to go through. Overlay was missing for the pin headers and could have been added. So as I spoke about this in the video, having that overlay in between your components allows you to visibly see how big your components are and where you should place your components. So if you see other boards, for example, if you took out a PCB or whatever from a project that others may have done, you will see that they do have that overlay across different components, and this is to help when it comes to placement so they do not overlap against each other. If you did overlap against each other, this would make it unmanufacturable. So with the pin header, it had that black plastic encasing around it to hold the pins in. Had I placed the capacitor closer to that, and maybe I didn't have like a keep out zone or whatever it was, a mechanical layer, I don't know, it would be unmanufacturable essentially. We couldn't manufacture those two parts because they'd be overlapping each other. Missing revision number on board and date. Details to keep track of what the board is and what its revision is. As I said before, this is a part of traceability, and you should really have revision numbers on your board to know which version is it, as we'll have notes or a trace record really of a date of when this board was done. And this is so when you have to come back and make changes, you know what was what and when the date these changes occurred and happened. This is so you don't build revisions over revisions on top of each other and you will lose traceability of what those changes were. Those changes are very important to keep track of. It may not seem like it, but come when you do the project and it might be something wrong, or you wish you knew which changes were actually made, it would be nice and you'll be grateful that you've actually included a revision number on these boards. C1 and C2 were incorrectly placed. As you've seen, the largest capacitor will always go first and then followed by the several smaller capacitors if you did have. In our case we just had 2, and even though in the schematic the C1 was placed first, so this was, I could not remember the value. So C1 is to go first, then C2. Largest goes first, then smallest, as I said before. Largest acts as a bulk capacitor essentially to prevent brownout and such. It also filters out some frequencies such as like noise and everything, so you get a smoother DC signal. And the smaller ones are also to help along with that for the higher frequencies. As a quick side note with that, perhaps the layout could have been much better, maybe closer to the pin, because you ideally want them as close as possible to the input pins of whatever device you are powering. I could have introduced more ground port around crystal lines, as you do not want the signal line near it. So what I mean by this is, if you have a crystal line as you've seen before, with a signal line in it, it could potentially induce noise from that crystal itself. And what this causes instability. You know, you do not want a noisy signal on the signal line. But in this case, it was just general GPIO, so I do not think it would be much of an issue. But for example, if we had an I2C line or we had a clock line or whatever, then this would be a big issue. Ideally, we don't even want to trace anything underneath it, so external routes or whatever. Last one was perhaps a brief note could be added for what the switch does, and we did have a lot of space on that board. And as I've shown before, there's a quick snippet of that, a brief note saying what does this switch do on the board, because when you come get the board and you may not lose schematic or someone else uses the board, you want to know what that switch does. You don't be fiddling through, and even something simple like programming voltage, use different voltage, you know, something simpler like that. As you showed the gas sensor, there was always a little label there saying this is battery, gas, or whatever. This was not only for me but for anyone else in the future, really. Even though you might be thinking, well, I'm doing this project for myself, I can easily refer back to the schematic. I think it's a good practice to get into to label itself down. This doesn't go only for switches. This could go for SD card connectors, SIM card connectors, so on and so forth. Maybe like little dip switches that you have. It's to give the user to know what they're actually dealing with instead of referring back for your schematic and such. So that was all I had for the PCB. Hope you did enjoy it. Hope you did learn something new, and thank you.